Hi there, welcome to the new lecture on designing security for data. So when we talk about the data with this specific module or with this specific lecture, we are going to focus on relational data, which is more about the SQL or the data. Let's say you got hired as a senior database administrator, where you're going to help to that company to secure the SQL database environment, and the company is based on an online sports goods retailer where they're going to save some kind of phone number of the customers and their address and credit card details, maybe in a SQL database, which is hosted in Azure cloud. And how you're gonna provide a solution, because there are few other employees who also have the access to the SQL server, but you wanted to prevent them for any unauthorized data access by anybody else from the team. So you, as a senior database administrator, how you're gonna design the security. So that's where you should be thinking this entire lecture. And beginning with that, as the senior database administrator, you should first think about what is the data you have and how critical it is, and how sensitivity and the business impact on that information, which is associated with the risk. So the risk association with the data is very important to analyze. So you could later point you could use some kind of encryptions, all of that stuff, but you first have to classify your data in a proper way. You need to identify what is the data. Let's say, is that data related to the data discovery? So what we can do is, basically there are three tenets of a good information to be protected. One would be the data for your disaster recovery, and the classification and the protection. So these three areas you need to protect the data by doing some kind of classification. When we say classification, you could actually think about larger companies or governments, or maybe think about even militaries. So military for the country, so they actually classify the data in different methods, like a public or confidential or restricted. So they could use the classification of the metadata, and that will enable us for the labeling the data. Let's say that could be public or confidential or restricted. So you have to first identify what is the data and what is the risk is associated, and the business impact and the sensitivity, all of that information. Then you need to classify the data into public, confidential or restricted, or whatever it is, customers data or whatever. And then you need to think about how you're gonna protect them. So this protection for your existing data, you could use encryption for a structured data. So when we talk about the structured data with encryption, you have encryption should happen at least the three main areas. One would be the data at rest, and other one would be the data in motion, and data in a process. So we will look at all of these things in detail in terms of the designing the security for the data. So when you talk about the designing security for your data, you need to classify, you need to identify the risk and the data importance and criticality, and then you need to classify, and you need to finally apply the encryption method, which is maybe a data at rest or data at motion or in process. And when we talk about the encryption, for example, data at rest, meaning we're going to use TDE, always encrypted kind of methods. And when we talk about the data motion, which is happening from one server to another client location, we might be using SSL or TSL option, or always we're going to use the encrypted method. And when it comes to the data in process, we might be using a dynamic data masking method when the data is processing. So these are the critical things that needs to be considered for any kind of data security. So the defense in depth is a strategy. Here is a slide that is segregated your defense of depth approach to protect your data. Let's say if you are talking about the network security, you could actually configure your VNets, firewall rules, NSGs, for protection. You could even use a private links to route from a private, and the firewall rules, NSGs, all that are going to protect your network from unauthorized access, or you could apply the rules and configuration. Similarly, identity and management. If you look at the identity and management, there are a lot of things within the identity and management. If you consider the authentication for Azure AD or SQL authentication or Windows authentication, these are three different authentications are there with any of the SQL servers. So you need to think about what is that authentication you are going to give it for consideration. And also the SQL with respect to, you could also use the Azure or back to protect from the Azure cloud point of view. At the same time, roles and permissions and role level security also can be applied as a layered defense. And also data protection, that we're going to talk about more about the encryption in a minute or so. Once we completed the security management or this slide specific, then we are going to talk about encryption. So we should be always recommending to go for encryption and use always encrypted method. And also we are going to talk about the encryption at rest, at the transparent data encryption, which is nothing but TDE, and also encryption in flight with TLS. And these are the options we're going to use for the data encryption in a combination of, you can use even your on-premises key management services to secure your data, or maybe as your key vault services in order to secure. And we're going to talk on that. And also you have the dynamic masking, which I'm going to talk in a minute post to this slide, which will be presentation layer respected to the security, because we talked about here the encryption end to end, and also at encryption at the rest, which is online offline method, and also the encryption in a flight, TLS. And when we talk about the managed keys, again securing the keys in your Azure Key Vault, or maybe a key storage from your on-premises can be utilized to give it as an added advantage, and securely you could confidently save the confidential information in the cloud. And we also talked about the dynamic data masking, like a credit card numbers or phone numbers or email IDs that you want to dynamically mask it when it has to present for your customer representative to validate the customer details. You could easily apply dynamic data masking options at the data protection. And also when it comes to the security management, you should look at the ATP, advanced threat detection, which is the next generation of antivirus with the AI and the ML based. And also you should be looking at the SQL audit logs and audit integration with log analytics and event hubs. That gives additional advantage in terms of what's going on in terms of the either performance or read write operations, everything. And also vulnerability would be the key to run the vulnerability assessment against your data, how it is secured. And also the data discovery and classification, we just talked about it from a security management point of it. We will be doing the data discover and also the classification, whether it's a public, restricted or confidential. We are going to apply that classification, and we are going to find out what type of data is there and how critical it is, and by using the data discovery methods. And finally, from a security management point of view, we are going to use a Microsoft Defender for Cloud. This is a equivalent to your antivirus for utilizing the cloud service for Defender services. This is going to closely work with your ATP also. So that way you're going to protect your data from a security management point of view. Let's try to understand how to protect the data at rest. Protecting data at rest is a mandatory step towards to the data privacy and compliance and data sovereignty. And the encryption helps definitely to mitigate the risk related to the unauthorized data access. And data at rest needs to be protected from unauthorized or offline access to raw files or backups that are completely unsecured on a servers, making a copy of all the data and transaction log files to another unsecured server. So this is where it can be used to protect it. And transport data encryption is the other option that within this. So when we talk about the TDE, that is nothing but the transparent data encryption, is going to protect your SQL database and Azure SQL managed instances and as Azure Synapse Analytics against the threat of malicious offline activity by encrypting data at rest. And it also performs a real-time encryption and decryption of the database and associated backups and transaction logs at the rest without requiring changes to the application. And in addition, transparent data encryption is by default it is enabled to all the newly deployed Azure SQL databases. With this, SQL managed instance or databases created after 2019. So that's where it's going to by default enabled. And if you also look at the TDE, that's nothing but a transparent data encryption and decryption of data at rest is going to happen at page level. When we look at the page level, meaning the data is encrypted at the data is written to the page on the disk and decrypted when data page is read into the memory. So at the disk it's gonna encrypt, and when you're trying to decrypt, it's gonna happen over the memory, and at the end result is all the data pages on the disk are completely encrypted. And data backups will also be encrypted because the backup operation just copies the data from a pages to a database file and the backup device, and the known decryption is done during that backup process. And TDE, that is a transparent data encryption, encrypts the storage of the entire database by using symmetric key called a DEK, which stands for Database Encryption Key, DEK. And this entire service is managed by TDE, where the DEK that's the database encryption key is fully protected with a built-in server certificate. And customers manages this transparent data encryption and also um, the DEK, which is database encryption key by their key management, and they are gonna own it, so it's fully protected and encrypted. And this uh, transparent data encryption uses the Azure databases with always on availability group. With that certificate will be used for encrypting the databases, must be backed up also and restored to the other services within the availability group in case if you try to work hard on a backup and restore by using the always on availability options. You might have to consider this also additional requirement. And also coming back to the key vault services with respect to TDE, transparent data encryption, you could actually use as your key vault services to store and access the sensitive data like passwords and certificates and keys, and it is centralized storage solution for your application secrets, and also helps to monitor how and when the keys and certificates are being accessed. And as your key vault, with respect to that, it can be integrated with other Azure services in an easy way, and the key vault data has its own RBAC access policies can be applied or separated from Azure subscription. So users need explicit access to the to be granted in terms of RBAC policies. In the scenario discussions at the beginning of this lecture, we talked about implementing a solution to protect the data at rest from unauthorized data access by someone that is working to support this cloud hosted database. And customers manage TDE bring your own key implementation. Uh, that is, again, transparent data encryption is a good solution for them for above scenarios. And also, transparent data encryption is going to protect that encryption by encrypting the database encryption key by using that a customer managed uh, key also can be used, which is stored again customer owned or managed by completely Azure Key Vault services. Ultimately, to protect data at rest, you could use the services that are available, for example, customer managed keys or Azure Key Vault services to secure by adding additional layer of encryption with your own keys. Let's also talk about the data protection in transit. When we say transit, it's in between. Let's say take some more scenario based examples. Let's say you have multiple workstations that are trying to connect by using your virtual network or VPNs. So how you're gonna ensure that the data is gonna accessed, or what kind of solution you're gonna offer, or securing your access from a individual workstation located on premises to Azure VNet, how you're gonna secure that in transit. And also take another scenario, move large data sets over the dedicated high-speed WAN link. Maybe you wanted a link, then how you're gonna uh, secure it with the Azure services. You need to think in that direction to protect the data in transit, which should also cover here interacting with your Azure storage through Azure portal, how you're gonna secure it. So these are the possible scenarios where you should be thinking to protect data in transit. So take a minute and think about it. Know what other solutions you could offer here, and if you can pause and think about it. Okay, now if I come back here with the possible solutions here, you could think about securing or connecting or secure access from a multiple workstations located on premises to your Azure virtual network. You could actually use site-to-site VPN to secure the solution. Let's say one location to another location, you could be using site-to-site. Whereas the on-premises access, that the securing access an individual person or a workstation located on-premises to the Azure virtual network, you could use a point-to-site VPN to secure, and you could apply the data to protect the data in transit. And also, if you're trying to access the high-speed wide area network, then you should be looking for Azure Express route. And integrating with the Azure storage, you should have an option to enable HTTPS with the REST API or HTTPS to interact with the Azure storage and SQL databases. So these are the possible scenarios that you have to protect with the data in transit. Let's also talk about protecting data when you're trying to use. By considering a scenario would be a right choice to explain this. Like you have a customer service representative is going to access your SQL database, and which consists of your phone numbers and email IDs and credit card details, all of that stuff. And the customer representative, when he receives a call from a customer, he has to verify that data whether it is really belongs to the customer or somebody else. So he has to validate. He shouldn't be seeing the exact credit card number, but he has to verify by seeing the last 2-3 digits. So how that can be implemented in your data protection policies. So that's where we come up with a solution within Azure called data masking. That's also you also have the dynamic data masking, means you no need to configure manually, it will automatically does that based on the discovery, the potentially sensitive data, and then it's going to apply that masking for you. So it's so easy for you in terms of masking. But let's talk about what exactly dynamic data masking. It's a policy-based security feature that can hide the sensitive data, and the result of the query, when you query that sensitive data, it's gonna hide by applying some kind of masking, so that you get that database fields as an output, but it will be in a hidden format, and you could easily identify by ending some kind of masking number. So it will help in it actually helps to prevent unauthorized access to the sensitive data by enabling customers to designate how much the sensitive data to revolve with minimal impact on the application layer. So that we need to think about it. So we could use data masking policies at the Azure portal for your Azure SQL databases. So if you could see here, in a SQL database table, the credit card information will be blocked and the last ending 3 digits only visible for your representative or customer representative when it was queried. And also you could similarly mask your email IDs, or maybe random phone numbers or random numbers can be generated. All of that stuff can be added just to secure the dynamic data masking option. And coming back to the data masking, it's actually works at the presentation layer feature, not actually storing, because when you try to actually query by, if you have the access to the data, you will be able to see exact credit card information. You don't need to mask at the presentation layer. But this is we are talking about the presentation layer, how much data we wanted to show to the customer. That's what we are looking into it. And also we also have the options like, once you implement, you have options to always encrypt feature for data at rest and the data in transit, so that it is fully encrypted. If we can separate the always encrypted word here, and that's gonna actually a feature designed to protect your sensitive data stored and a specific data columns from accessing, for example, credit card numbers or national identification numbers or your confidential information. So this includes your SQL database administrators or other privileged users who are authorized to access the data to perform management tasks fully encrypted. And the data is always encrypted, which means the encrypted data is decrypted only for the purpose of the client application, not even for your database admins or whoever have the full privileges. In the previous example, the data masking we used, customer can be able to view, because we are just applying a data masking at the presentation layer. But when we talk about the always encrypted, you cannot see that information. Only the application itself can see that information. That's how it's gonna use. And this is works in a lot of steps will be involved for the always encrypted method. But if you just look at always encrypted, it's gonna use two types of keys. One would be the column encryption, and other one would be the column master keys. So this column master or column encryption key is used to encrypt the data and encrypt column, and the column master key is a key protecting the key that encrypts one or more column encryption keys. So this is some kind of internal logic that is going to use by Azure database for encrypting the entire data so that it's a fully encrypted at the data rest as well as in the transit. So you cannot see the data unless if you are in an application, and this database only stores encrypted values of your column encryption keys and the information about the location of that master key column, and which are stored in an externally trusted key store. For example, you could use that encrypted for this purpose of full encryption. You could store the keys maybe in a Azure Key Vault, or maybe in a Windows certificate store, or in a PKI. There's a public key infrastructure store. So that's what you can use. And just moving further to conclude and give a great value for your always encrypted for data rest and data in transit. You could always encrypt ensures the separation of duties. So when I say separation of the duties between your database administrator and the application administrator, you need to separate them by storing always encrypted key in a trusted key store hosted on premises, not on a cloud. And that way it's going to ensure that Microsoft Cloud administrators have no access to sensitive data, because you use the encryption key which is in your on-premises. And that's a great option to encrypt your sensitive data. And always encrypted enables customers to confidently store sensitive data outside of their direct control. Hope this lecture is useful in terms of taking the considerations for designing the security for the data. We start with the three basic tenets of the good information to protect, like data discovery, classification, and protection. And then we also classify what type of that data is a public or confidential or restricted. And we also think about the data protection in terms of the encryption methods at the data at rest, data in motion, data in process. In all of these life cycle, we are going to securing the data. Thank you for watching this. We'll catch you in the next lecture.